Today, on October 25th, 2025, we stand at a fascinating crossroads in agriculture. The challenges of feeding a growing global population while protecting our planet are immense, but our tools have never been more powerful. I have constructed a small model, a blueprint for what a future farm might look like. This is not just a collection of parts, it is an integrated system, a farm with a brain driven by artificial intelligence. It represents a new way of thinking about how we grow our food, one that is more efficient, more sustainable, and more in tune with the delicate balance of nature. This model shows how we can use technology not to replace the farmer, but to empower them with a deeper understanding of their land and crops. The core idea is simple: to create a farm that makes intelligent decisions on its own. Imagine a system that knows precisely when a plant is thirsty, detects a pest before it becomes an infestation, and transforms agricultural waste into a valuable resource. It is a vision of farming that works in harmony with its environment, conserving precious resources like water, land. We can grow more food in smaller spaces, reduce our reliance on chemical interventions, and even create new income streams for farming communities. Before we delve into the construction of each component, let us appreciate the complete picture. You can see the central, multi-story growing structure, a vertical garden reaching for the sky. Beside it, two separate modules, a miniature factory for converting crop residue into fuel, and a transparent smart seed lab for optimizing our planting choices. A tiny mobile scarecrow stands guard, ready to patrol the area. Each piece plays a critical role in the farm's ecosystem. This is a cold open to our exploration. The centerpiece of our model is the multi-story farming structure, a concept that fundamentally changes our relationship with agricultural land. Instead of spreading outwards across vast acres, we build upwards. Our model is a tall, box-like frame constructed from sturdy plywood, with clear fiberglass walls acting as windows. This transparency is crucial. It allows maximum sunlight to reach every level. The structure is divided into several floors, each one a dedicated growing space. By stacking these layers, we multiply the productivity of a single small footprint, ideal where land is scarce or expensive. On the roof, a large flat surface with a sliding glass panel serves as a dynamic skylight. The AI can automatically open or close this panel to regulate direct sunlight and temperature. Access is provided by external stairs and a small ladder for rooftop maintenance. Equipment like solar panels can sit on the roof. Each floor hosts specific plants, creating a diverse ecosystem within a single building. Lower floors with softer light suit, leafy greens, lettuce, spinach, and herbs. Middle floors for trellised tomatoes and peppers. Top floors for sun lovers, strawberries and other small fruits. Building this structure is a straightforward process. We begin with the plywood base and erect the four corner posts. The floor platforms are slotted in at regular intervals, creating the different stories. The clear fiberglass panels are fixed to the frame, enclosing the structure while maintaining visibility. Finally, the stairs ladder and sliding roof mechanism are added. The tools are simple: a saw screws a drill, a strong adhesive for the fiberglass panels. The result is a robust and transparent tower, a miniature vertical farm ready to be brought to life with plants and technology. The purpose of this demonstration is to make these advanced concepts accessible and clear. We will break down each part of the model, step by step, showing how it is built and explaining its function in simple terms, from the plywood and fiberglass base to the intricate wiring of the sensors. These are practical solutions that can be implemented, an educational tool, a conversation starter, and a symbol of hope. Let us begin this construction together. If the vertical structure is the farm's skeleton, then its sensors and flooring are its nervous system, constantly feeling and responding to the environment. We have embedded 5 distinct types of sensors throughout the model, each acting as a digital nerve ending. Water sensor. It monitors soil moisture levels, ensuring plants are never too dry or overwatered. Gas sensor. It detects gas levels in the farm that could indicate disease or poor ventilation. Insect sensor. It alerts farmers to pest presence before infestations grow. Seed quality sensor. It ensures high-quality seeds. More on this in the seed lab. pH level. Sensor. It monitors soil pH for good growth and nutrient absorption. All sensor data flows to a central system, the farm's brain, where AI processes streams of data in real time. If floor 3 tomatoes report low moisture, the AI activates irrigation for that specific zone. If unusual aphids are detected, it sends a phone alert with a photo and recommended action. In our model, we visualize status changes with small, color-coded LEDs. Beneath the plants, the flooring is active. A water-absorbing top layer reduces runoff and holds nutrients close to the roots. A transparent underground layer ensures water passage and lets us observe root growth. Pipes harvest rain, store it in a reservoir, filter it, and reuse it for irrigation. A closed-loop system. In the model, simple plastic tubing represents this efficient plumbing network. Post-harvest stubble, from wheat and rice, is often burned, releasing smoke and pollutants. Our AI farm model adds a separate factory module on its own base to transform waste into value. This turns an environmental problem into a revenue stream. First, stubble is collected and shredded. The starch within is our target. Through enzymatic hydrolysis, enzymes convert complex starches into simple sugars like glucose. Next comes fermentation, an age-old process used in bread and beer, where yeast consumes sugar without oxygen. It produces carbon dioxide and ethanol. Our sealed container with a small gas outlet shows the reaction taking place. Distillation gently heats the mix. Ethanol, with a lower boiling point than water, evaporates first and is condensed to purity. The bioethanol can power farm machinery and generators, and could be refined into sustainable aviation fuel. Our model completes the journey with a labeled bottle, from waste to wealth. Note the factory sits on a distinct plywood and fiberglass base for clarity and modularity. This innovation reduces pollution, generates clean energy, and creates income for farmers. A compact biorefinery, practical, profitable, and sustainable. Crop protection, seed selection. Our model uses AI for both, starting with a walking scarecrow. This is not a stationary straw figure. A small wheeled robot patrols the perimeter, moving slowly and autonomously. High-definition cameras, a suite of sensors, motion detectors, and thermal detectors scan the fields for threats, the farm's vigilant guardian. The intelligence lies in differentiating threats from non-threats. It recognizes deer, rabbits, specific birds, even a herd of blue cows as a danger, while ignoring cars on nearby roads. On genuine threats, it sends an immediate alert to the farmer's smartphone with video. It can activate deterrents, flashing lights and targeted alarms. On the other side sits the Future Seed Lab, a small transparent box, the Smart Seed AI corner on its own base. Inside are labeled seed samples and microsensors. Soil data, pH, moisture, and nutrients is fed from the main farm computer. The AI cross-references a seed database and recommends the optimal variety, displayed on a small integrated screen. Each compartment has a QR code. Scanning reveals ideal planting depth, germination time, disease resistance, and projected yield, connecting a seed to global knowledge. A simple, clear box becomes a powerful decision-making tool, ensuring every seed has the best chance to thrive. Together, our AI-driven farm model showcases innovative techniques for a sustainable future. Smarter, cleaner, and more resilient.